Okay, this is 1011 worksheet problem 9. Okay. All right, I feel like this is a really good problem for you guys to work on. This one and problem 4, which I gave a solution to in the video for that. Because here you're rearranging strings, trying to figure out the number of ways you can rearrange strings and leave certain things fixed and stuff like that. You're definitely going to do stuff with, like, you're going to work with strings, definitely. As computer scientists, as programmers, whatever you decide to do. And these problems are really cool because they don't, it's more just about sort of logically reasoning your way through it. It's not too heavy on the math. And it really is just about reasoning your way through these things. Okay, so let's reason our way through this. All right, so problem 9 on the 1011 worksheet. Let's see. All right, so we want to compute A1 union, the cardinality of A1 union A2. All right, by inclusion exclusion, that's cardinality of A1 plus cardinality of A2 minus cardinality of A1 intersect A2. Okay. So first let's look at the cardinality of A1. Okay, so I'm going to look at that right here. All right, so the cardinality of A1, right? So as you can tell from your worksheet, this is the rearrangements of the string 1, 1, 2, 2, 3 that contain the string 1, 1. So they're all the different rearrangements that leave the 1, 1 block fixed. All right, so these strings are length 5. All right, so this is going to, this follows very similarly to problem 4 on this worksheet. All right, so the way to go about this is to first count all the different ways that you could, so we'll separate this into 2 parts. Part 1i and then 2i. I guess 3 parts, just like was done in problem 4. I spent a lot of time on that problem in one of the videos. Okay, so anyway, so we're going to look at, so we have a string of length 5, 1, 2, 3, 4, 5. So we got 5 positions. 5 positions. And now we want to, so we got to leave the 1, 1 block fixed. So we got to think, okay, where can we put the 1, 1 block? So think of all the different, so how many different places can you put the 1, 1 block, right? So you could put the 1, 1 block there, in that spot. It could be there. It could be, let's see. You could put it there, right? You could put it there. You could put it there. You could put it there, right? So there's 4 different possibilities for that. Another way to look at that is to say, okay, they could go right there. They could go right there. They could go right there. Or they could go right there. So 4 ways to position the 1, 1 block. Okay, now 2, once we position those 4, once we choose one of those 4 ways, 1, 2, 3, 4, right? One's there, one's there, one's there, one's there. Once we choose one of those 4 ways, then how else can we position things? Okay, so let's just say we chose the 1, 1 to go there, right? Looking at that one, there's, remember, so there's 4 choose 1, otherwise known as 4. Remember that n choose 1 is n. All right, so there's 4 choose 1, otherwise known as 4 different ways to position this 1, 1 block. If we have this one, then how many different ways can we position the 2 2s and the 1 3? Right, so there's 3 positions left over. So we have 3 choose 2 ways. You have 3 positions, choose 2 of them for the 2 2s, and then let's say we chose those 2, then that one's determined. There's 1 position, choose 1 of them, otherwise known as 1, for the remaining for the remaining 3. All right, so the answer for this one, for the cardinality of A1 is you have 4 ways to position the 1 1 block. So you have 4 choose 1. That's where to put the 1 1. Okay. Where to put the 1 1 block. Once you choose where that 1 1 block goes, maybe let's just do another one real fast. Let's say I chose the 1 1 block to go there, right? Then you can see I have 3 positions left. Choose 2 of them to be 2s. Then I have, let's say I chose, you could just put them together. Let's just put one like that. Then you have one position left. Choose that 1 position for the 3. Okay, this is 4 choose 1 is 4. 3 choose 2 is 3 choose 1, so that's 3 times 1 equals 12. Okay, right. Okay, why did I get 90 there? All right, perfect. Okay, all right. So here we have 12 plus 12 minus, we just got to figure out this number here. Okay, now maybe you're saying, okay, how did I get that second 12 for that one? Notice this will be exactly the same except for A2, except for instead of 4 ways to position the 1 1 block, now we're looking for 4 ways to position the 2 2 block. That's A2. All right, now let's look at figuring out A1 intersect A2. All right, now let's see. Okay. All right, so just very similar to what we did in problem 4, part B. Now the way we're gonna figure this out is we're gonna think about all the different ways that we could position the 3 block. Right, this is A1 intersect A2. This is the number of rearrangements of the string 1 1 2 2 3 that leave the 1 1 block fixed and the 2 2 block fixed. All right, so we've got, so first thing to do, let me give yourself some more room here, is you got 1 2 3 4 5, 1 2 3 4 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's see, 1, 2, 3, 4, and then 1, 2, 3, 4, 5. Okay, so here I've got, so now I'm going to think about where could I possibly put that 3? Right, where could the 3 possibly go? All right, so notice that if the 3 goes there, that's okay, right? Now think about, let's just go, first I'll go like this, then we'll talk about it. Okay, so could the 3 possibly go there? If the 3 went there, right, then that would break up either the 1, 1 block or the 2, 2 block, and that's not going to work, right? So we get rid of that one. If I put the 3 there, that would break up the 1, 1 block or the 2, 2 block, right? So there's 3 ways you can position the 3. Okay, so there's 3 ways to position the 3. Position the 3. Okay, so we got that. 3 ways to position the 3. Okay, now once we choose one of those 3 ways, all right, I think this is was part I and part B of problem 4. Okay. Now let's just take one of those, because it's going to be the same no matter which one of these you use. Okay, so once you choose one of those, now how many different ways can you position the remaining 1, 1 block and 2, 2 block, right? So once you choose one of those ways, let's see, you can put 1, 1 there and 2, 2 there, or you can put 2, 2 there and 1, 1 there. So it's 2, right? It's just really 2. Another way to look at it is you have 2 places you have 2 places you could put the 1s. Choose one of them, right? There's 2 places you could put the 1s. Choose one of them. Then there's 1 place to put the 2s. Choose that 1 place. All right, so this is 2. Right, so then for that, so cardinality of A1 intersect A2 is you have 3 ways to position them. 3 ways to position the 3. Once that's chosen, then there's 2 possible ways to put everything else, and so then you have 6. 12 plus 12 minus 6. So let's see, 24 minus 6. Let's see, that's 18. 6, 12, 18, 24, so that's 18. All right.